Hey, welcome back to the lesson on transducers. So today, not today, but for this lesson, we are going to be talking about some other common transducers and their functions. Okay, so we're going to be talking about IR diodes um, and how they are usually paired with photodiodes. Diodes, you should kind of know what they are and what they do. So this is a special kind of diode. We're also going to be talking about microphones. Uh, and I think that's the time that we have for today. Get to know these two. And then for the next video lesson, I'll talk about the rest. Okay. So as I said, we're going to be talking about the first pair of transducers. Yes, they are usually used as pairs, IR diodes and photodiodes. So okay, so IR diodes, you actually use them a lot. Okay, I don't know whether you know it, but in almost all of our TV controllers, in almost all controllers, there are IR diodes embedded in the controllers. Our smartphones used to have them too, but nowadays it's considered an older technology. So very few smartphones have the IR blasters anymore. Because everything is controlled by Bluetooth or Wi-Fi on these fellas. But for the TV remote, a lot of them still use the IR diode. Yeah. So like I said, but they usually come in pairs. Yeah. So when the IR diode, you press a button, it shoots out IR signal, and your TV here will have a sensor. I don't know where that sensor is, but it goes into the photodiode on the receiver. Okay. So that's how the IR photodiode works. It always works as a pair. Yeah. So as I said, the IR diode is an LED. Yes, it is an LED, but it only emits infrared waves. So you can press it all day long, but you won't see anything coming out of it. Yeah. Infrared waves are part of your electromagnetic spectrum. You will learn it in the chapter on lights. I think some of you have already done so. Yeah, and this is the symbol for the IR diode. So you got to learn how to uh, draw it. Yeah, and from the length of the legs, by now you should already kind of know that because there's a different length, this fella has polarity involved. Okay, so as I said, it is always used as a photodiode IR diode pair. Okay, now here's the funny thing about the photodiode though. You have to use it reverse bias, whereas the IR diode, you just put it as a forward bias. But for the photodiode, you have to put it as a reverse bias. Okay, so this fella, the photodiode, only allows current to pass when it is exposed to IR rays. Okay, so that's how it works. It gets IR rays, it allows current to pass. Okay, so the more IR diode it gets, the higher the current it will allow to pass. Okay, so same thing, know how to draw the symbol. A photodiode usually is colored black. Usually, there are some which is also clear in color, but then it kind of gets it very, very confusing as to know which one is the photodiode, which one is the IR diode. So the ones we have in the lab, photodiode is a black, and the IR diode is the clear casing. Okay, so the difference in between the IR diode shoots out infrared waves, and the photodiode receives the infrared waves. So that's the difference between the two symbols. And this is classic setup, how we use a photodiode IR diode pair. So this is your IR diode. Okay, it has its own power source. And so this is how it works, right? When there is nothing blocking them, the infrared waves comes, and once this fella senses the infrared waves, it allows the current to flow. And once the current flows, using Ohm's law, you are going to have IV equals to IR here. Okay, so you have a V out. However, when I have something blocking, when I have something blocking in between the IR and photodiode, this means that the photodiode is not getting any infrared waves. And if there's no infrared waves coming here, there will not be any current. So no current, and if there's no current, no I, if I is 0 or near to 0, means V out is also 0 or near to 0 volts. Okay, so depending on whether you cover it, or sorry, not cover, depending on whether you put something in between them or not, we can change the V out characteristic. Okay, so yeah, so that this can be applied for a number of setups. So this is the classic setup that a lot of you will use. In fact, one of your projects will involve this. Yeah. So one setup could be used to keep count on the number of people who walk past. So every time a person walks past this IR diode pair of IR photodiode pair, the V out changes. So when V out changes, you can put it into another subsystem through the process, and it can come out with an output for you. Can count as a number. If you put the 7-segment display as the output, something like that. Okay. The next thing that I want to talk about is microphones. Now, microphones, take a minute to think whether it's an input or output transducer. Sorry, before we go there, this is usually an input transducer pair because it takes a physical change to translate into an electrical signal here. Okay. So what about the microphone? I speak, the sound enters here, and I get an electrical signal here. So this is your input transducer where so it's an input transducer, converts sound energy into electrical signals. Okay, so all microphones have a very thin material called a diaphragm, and this vibrates according to the sound waves that it receives, and this vibration causes a coil of wire. The vibration causes a coil of wire and a magnet to change, and this vibrating coil of wire through a magnet generates your electrical signals. So microphones, as usual, used in a lot of places, in handphones, yeah, smartphones, microphones. This is a guitar tuner, and even here, there is a microphone here, right? So this is the symbol. You have to learn how to draw the symbol of a microphone. Looks a bit weird, but yeah. And the microphone that we have in a lab is called an electret microphone. This is about the size of an electret microphone. Cheap, yes, we are on a budget here, but it works-ish. So yeah, that's what we got to work with here. Yeah. But okay, so you gotta know that the microphone has polarity. It's got a negative and positive terminals. It is not going to be listed down. So this is how we're going to figure out which is the positive and negative. We're going to put the multimeter to measure resistance, and we're going to put one leg on to one probe and the other probe onto the casing. So and do the same for the other leg. So the one which has a lower resistance would be the positive terminal. Okay, so just keep this in mind. Yeah. Now, once you have identified it, this is how you hook it up. Always put the positive. Sorry. Always put the positive in line with your power source. Usually we use between 3 volts to 12 volts, and your negative to the ground. Okay, so the sound wave comes in here, it changes into your electrical signal here. Okay, um, to kind of help you understand a little bit more about why we put uh, a polarized capacitor here is to let in your AC signals, but to block your DC signals. Okay, so how this works, you can watch it in this video here. Yes, my favorite YouTuber. You go and search for electro boom, how capacitors work. You will have already watched this video in your previous chapters. Start at about 7 minutes, okay? So he'll explain to you how a capacitor allows AC signal to go through, okay? And what he's also done is that he's also kind of created his own microphone using a lighter. Yes, so go and search for Electro Boom. Lighter is a microphone. Take a look at this. Is pretty interesting and quite ingenious what he did. Okay, so I'm going to stop here before I go on to the other transducers. Go and watch the 2 videos by Electro Boom. Have a good laugh, and then come back to the next part of transducers video lesson. See you in a bit.